Oh, that'd have been, I would have been recording. That would have been really nice, right? Oh, well, I suck. Okay. Let me see who's talking to me. Oh, sure. Okay. And again, if it still doesn't quite make sense, you can still ask more questions. That's fine. It's all about patterns. A huge chunk of mathematics is noticing a pattern, and look what they do next. I mean, this is the part that I thought was going to freak people out. The next thing we do is we notice the pattern and we construct an equation, because what if I want to know the 812th pentagonal number? Do you want to just keep going? You want to just do this until you get to the 812th picture? No, I'd rather have an equation that I can plug 812 into, and it tells me what the 812th number is, the pentagonal number. Does that make sense? This is the most basic reason we create equations, is to decrease the amount of work we have to do. Believe it or not. I know most people see equations as more, it's just more work for me to know. It's actually less work than it would have been without the equation. Okay. I don't know. Is that all right? Is that terrible? Is that all right? Okay. All right. I don't see anything, so I'm going to assume that's good. Any other questions from homework? The pattern for the Pentagon. Oh, be careful. No. Be careful about that last number, right? It goes from 12 to 22. It's not 11, right? Sorry, somebody's private messaged me. Now, yeah, exactly. So now can you see the pattern? You add 4, and then they added 7, and then they added 10. So what's the next thing you're going to add to get the next number? 4, 7, 10, and then they're going to add what? They added 4, and then they added 7, and then they added 10. What's the next thing they're going to add?
13.
Yeah, because they keep adding a number that is 3 more than the last number they added. Boop, 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 boop. Okay. All right. Okay, anybody else? Is that all right? Anything else, guys? Do. I need everybody to get deeper into chapter 4 and bring questions. Because as always, some of these problems are weird. They're not supposed to be. Some of them are easy. Some of them are really easy. Some of them are really weird. So it's fine. If it doesn't make any sense, you go, well, this might be a weird one. Let me ask a question. All right, I'll stop. Let's see. If nobody else has anything else, we're going to get back into where we left off. And I want to show you something. Let me see. Oh, yeah. Is this the one? No. Oh, Jeff, you lost it already. Where'd it go? Oh, no. Oh, no. Did I lose it? You doofus. Maybe it's here. All right, hold on, everybody. Sorry. Okay, here we go. What page is this? You can do it, Jeff. Page 5. Okay, good. I'm sorry, guys. Stay with me. So I have located a study. Let me see. Wait a minute. Let me show you what I do. Well, I can do that here. Yeah. I've located a study about. Now, I'm sorry. It's about COVID-19. I'm very sorry. But it is about when they reopened schools in Texas. There's evidence now that led to increasing the spread of COVID-19 in a big way, right? So it's the one thing I want to show you. So this is all about, they did a study. They had some high schools reopened. they saw an increase in COVID-19 cases. You have to do a study to make sure that that one thing caused the other thing to happen. Are you guys with me? So this study is all about that, and it's freaking long as shit. I mean, look at this. Wow, it's long as shit. But the most important thing I want to show you is right here. Where'd it go, Jeff? I don't know, man. Why don't you just do this? There it is. And there it is. All right. To illustrate 95% confidence intervals from the baseline regression plan, school reopenings across Texas led to at least 43,000 additional COVID-19. Okay. The main thing right there, 95% confidence intervals. Do you understand? Almost every statistical analysis that you open up, that you see in a magazine, that you see in a journal article, that you see whatever, they are going to create these confidence intervals. Do you guys understand what I'm saying? Because they give an idea about from what to what. So to be conservative, they went with the lower estimate. So it was at least 43,000 more COVID-19 cases. Okay. No, is that not good? Is that bad? I always try to show people, hey, look, this stuff we're doing, here it is in a real world place, right? I try to find more studies. This one didn't really give me much. This one got a little too technical. But what I do is I type the word study in, and then I go past week, and then I get all these studies that have been done in the past week. Anyway, yeah, blah, blah, blah. So I'm not going to show you. So almost any article you pick on, you click on, you're going to see confidence intervals being created. Is that to leave room for error? All right. So the whole idea, all right, now listen, guys. All right, let me see. All right, you ready? So it's a beautiful question. I can do this right now. I was going to do this eventually, but it's a perfect time to do this. Everybody wait. All right, so here is the idea. Stay with me, stay with me, stay with me. Here's the explanation of what 95% confidence means. I'm going to go up on the board here in a second, but let me ask you this. Does anyone know the probability if you flip a normal coin that you get that it lands on heads?
50-50.
Why?
Because there's two faces on the coin.
And they're both equally likely.
Yep.
Now, if somebody weights the coin in such a way that it lands on heads more often, then they're not equally likely. So it won't be 50-50 anymore. But for a normal coin that nobody screwed with, it should be 50-50. If I flip the coin once, what does 50% mean? It's going to be heads or tails, correct? So it only means something if I do something a lot. If I flip the coin 8,000 times, how many would you guess would come up heads? If I flip it 8,000 times, go ahead. Sorry?
Somewhere around 4,000.
Somewhere around 4,000, exactly, because I would expect about half of them, because that's the probability of getting it to land on heads, right? I like it. Maybe. Now, the second thing you should do if you're flipping a coin 8,000 times is reevaluate your life choices. Something's gone wrong if you're flipping a coin 8,000 times. Now, here's the thing about confidence intervals. Okay, all right. All right, we haven't really talked about them a ton, but we have talked about them a bit. So let me remind you a little bit about what we talked about. So what a confidence interval does, okay. Stay with me, stay with me. So for example, if I made a 95% confidence interval, is everybody cool with CI is confidence interval, right? And let's say it's I get 72% plus or minus 3%. So what would that interval be? What would be the low and the high for this interval? 72%, give or take 3%.
75
Would be the high.
and 69.
69% would be the low. I like it. Right? So somebody told me, we think it's 72%, but here's our confidence interval. That to me is pretty good. That's pretty focused, right? But what the shit does it mean? What does it mean, Jeff? Right? Stay with me. Stay with me. What are we? All right. So if we're talking about the percentage of students who pass Math 96, right? Let's say that's what we're doing. You with me? The percentage of all students who pass 96, right? Who take it and pass it. Let me stop for a minute. If you wanted to estimate that, can you talk to every student who has ever taken Math 96? Do you even want to? Would you want to take the time to track down all the people that have taken Math 96 and talk to them?
No, you'd have to take a sample.
Yeah, of course you'd want to take a sample so you can talk to fewer people, but you want it to be representative, correct? You want it to be random, right? If you only picked people that you knew, that would be biased. All right, is everybody with me so far? So course in statistics, we take a sample because most of the time we don't have the time to get the whole population. Okay, let me stop for a minute. Okay, this is normally the stuff we know about statistics already. We all know we get samples. We don't talk to every American when we're talking about percentages of Americans that do stuff. There's no way we could talk to everybody. So would you agree that there is a true percentage of all students who pass 96? Would you, that there is a, no? Wait, when was that written? I'm sorry. What's the no for? Or is that from earlier? I'm sorry.
The no was earlier, like, would you
Okay.
want to drop them all down? No.
Oh, okay. Stay with me now. Obviously, there is a actual percentage of all gross month students who have ever taken Math 96 who passed it, correct? You guys agree? There has to be a percentage that exists, right? If we could talk to everybody who's taken or analyze records of every student who's ever taken Math 96, wouldn't we figure out the real percentage, correct? Stay with me. This is so cool. Stay with me. Come on. So there's a real percentage. We'll call it P. When I take a sample, do you think that's going to be the real percentage? From when I take a sample, do you think I'm going to get the real percentage? No. Does that make sense? If you took a sample of students and took their ages, are you going to get the real average age of all gross month students? Hell no. Most likely not. It's just a sample, right? So stay with me. So we're going to get like a percentage, like 72% might be here. And then when I make my interval, right, the plus or minus 3%, my interval has a 95% chance of containing the right percentage, of containing the true percentage. So another group of people could come, get their own sample and get a p hat up here. And then their interval would be like this. Right? Are you guys understand? If I get a different sample, won't I probably get a different percentage from that different sample of people? Yes.
Yes.
Yes. Even if it's purely random and it's really representative, because it's a sample, it's probably going to be different. So what this means is if 100 people created their own intervals, 95% of them would actually capture this guy. So every now and again, you would get one that was like up here. Does that one contain the real percentage? No. How often would that happen? 5% of the time. I have no idea if you guys are with me or not, but that's what it means to be 95% confident that our interval caught the real percentage. 95% of all intervals people could make would capture the real percentage. So there's a 5% chance that I made the shitty interval that didn't catch the real percentage. Oh, shit, everybody's like, what does this mean for me, Jeff? What do I have to do in the homework with this? The nice thing in the homework is you're just going to be calculating this stuff, right? You're not going to have to really understand everything I just said, but hopefully a little bit of what I just said made some kind of sense, is my hope. Oh,
Excuse me, Professor.
yes.
Can I ask you to please repeat it again on and use another words or other words because I couldn't understand some of your words.
You have to let me know immediately when that happens because I don't know which words. Okay, so all right.
Your last sentences.
All right, now listen. Would you agree there's a percentage of students in this class that show up to class regularly?
Yeah.
Okay, and this is for everybody. If I took a sample of students, I would get a percentage of the sample that I took, the small group, that show up to class regularly. Yes? So
Right.
there's
Right.
29 students, I think, in this class. I can't remember now. 29, I think it is. And I could take a sample of those 29 and see what percentage of that sample showed up to class regularly. Do you think that the percentage I get from the small group will be the same as the percentage of everybody?
Yeah, it can be.
It can be, but do you think it would be?
No.
Probably not. Good. So if 100 people picked 100 different samples from this class and created confidence intervals, 95% of those intervals would actually contain the real percentage of the whole class.
Okay, I got it.
All right. It's a weird idea. And again, you don't have to understand this whole thing to really be able to do this section. I'm going a little bit deeper than I necessarily need to, but I just want to tell you what that means since we're talking about it. Trisha's got a question about how can you be sure that it's 95%? Take statistics and find out. It's a long process to understand the mathematics and the concepts behind what goes into this. So we are using, anyway, let me see how, so let me do a concrete example. And I want to point a couple things out related to that question. So the formula for constructing so first you have to figure out what P hat is. It's the percentage from the sample. Then you have to construct the what's called, I can't remember this book calls it this, the error. This is the plus or minus piece. Stay with me. What's happening? You guys all right? Okay. This is the part that's got the formula with it. So it's 2 times the square root of the percentage from the sample times 1 minus the percentage from the sample divided by n. So, for example, And I told you, so this formula right here, if you take statistics, you will see how this formula is constructed. And I told you one little thing, this number is related to it being 95% confidence interval. If I wanted to be more confident, this number would go up. If I was okay with being less confident, the number would go down. So there are a lot of concepts that go into this formula. So why are we talking about it in this class? Because it's something you guys see. You guys see the plus or minus 3%. If you see any articles or polls or anything, you see it out in the real world. And it's kind of nice to know where that comes from. And it's a little teaser for 160. So for example, a concrete example. All right. Yeah, all right, let's say I talk to what do you got, Jeff? 407 Math 96 students. They took Math 96 sometime and find what do you got, Jeff? 295 of them passed. Oh, that might be a little bleak. I don't know. We'll find out. Can somebody help me? What is P hat? The little hat on this means it's a percentage from the sample. That's all it means. It's a percentage from the sample. If it wasn't wearing a hat, it would be a percentage of a whole population. How do you calculate a percentage from the information I gave? What percentage passed?
295 out of 407.
I love it. Does somebody help me out? What is that? I think it's 73%. I don't know. I just did that in my head.
72. You were really close.
Man, I wasn't close enough. Oh, I see. So let's say 0.725. Are you guys, can you do that on your own? Can you get that?
Yeah.
Everybody got that okay? So what is 1 minus P hat? I might as well do that right here. I've got to plug it in here eventually. What's 1 minus that?
-1 point.
What happened? 1 minus this. I'm not sure what you put in there. 1 minus this.
275.
Yes, 0.275. So if this represents the percentage you passed, what does this represent?
The percentage.
They no pass.
Good, there you go. They know pass. So this is the percentage that passed. This is the percentage that didn't pass for whatever reason. Maybe they withdrew, whatever. You guys okay out there? Everybody okay so far? We haven't done a lot. I didn't say that to make you feel bad if something doesn't make sense. I'm sorry. Does everything make sense so far?
Yes.
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 All right, I got 3 people. Okay, so now I can use this formula. I can figure out the error. That's the plus or minus piece. So it's going to be this plus or minus what I get from this. So let's figure this out. It's going to be 2 times the square root of 0.725 times 0.275 divided by n. What was n? What's n in this problem?
407.
Good. Total number of people, 407. All right. Take a minute and do that. I'm not going to try this in my head, although as I say that, I want to. But just don't, Jeff. Just don't, shall you? Bam. Anybody get that yet?
0.044.
Like it. So now how do I do my interval? Well, it will be 0.725, give or take 0.044. If you'd rather, you could actually change them into percentages, right? 72.5%, give or take 4.4%. I don't care. Right? Make it into a percentage, make it into a percentage. Can you add that and subtract that and tell me what the interval is? So you just got to do 72.5 minus 4.4. Does anyone get that?
$68.1.
68.1%. I like it. And then plus 4.4.
$76.9.
76.9. That's right. So my interval is from 68.1% up to 76.9%. So if somebody said, hey, what's my chances of passing Math 96? And then I give them this interval, this gives them an idea. And of course, individually, you can increase your chances by, I don't know, studying, doing homework, attending class, blah, 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 right? So this isn't like your fate, right? This is something you can change. Maybe, I don't know, maybe. That's the kind of work you got to do in this homework. Putting the formula together and then figuring out the interval at the end. Everybody hated that. All right. Can somebody tell me how far off we were in our estimate? Here's our estimate. How far off was that?
4.4%.
4.4%. Stay with me, stay with me. What do you think would happen if I had taken a larger sample? What would happen to that error if I took a larger sample?
It would change.
How? Would it go up? Would it go down? Do you not know?
Could be either or.
Nope.
On how large your sample was.
If I increase this, what happens to this?
It'll get smaller.
Cool. So everybody get that? Now I would entertain, Trisha, if I take a larger sample, these two numbers could actually change also, right?
Yes.
But the thing that affects this the most is this number, to be honest. But you're right, these two numbers could change, that could throw it off a little bit, but overall the trend would be this would go down. Okay, I like it. Okay, now, with what I just said, with what we just agreed with, I know. But doesn't it make sense? I mean, the larger the sample I take, the less error there should be in what I see. Isn't that something you guys already knew before I said anything to you?
Yeah.
It's better to take a bigger sample. Why? Because then we're more sure about what we see. And now we see the math behind it. The bigger this is, the smaller the error is. Okay, that's beautiful. So shouldn't I be able to figure out how big this number should be to make that 3%? Let's say our boss is like 4.4% isn't good enough. I want you to talk to more people to make it 3%. And we're like, how many people would we have to talk to? We should be able to figure out what n has to be to make that happen. Does that make sense? I already know that if this goes up, this is going to go down. Well, now I just want to know exactly what would this have to become to make that 0.03. Oh, shit. So now, what do I have? So we now want the error to be 0.03. So that means that I want twice the square root of 0.725 times 0.275 divided by something. I want that to be 0.03. And so what do we put down there? We'll just put n because we don't know what that's going to be yet. I know if I put I know if I put 407 here, the error is too big. I want it to be just this. I have no idea. Is anybody understanding the idea right now? If I put a 407 there, I know I'm going to get 0.044. So if I just leave this unknown, I can figure out, okay, what does this have to be to make it 3%? That's better. Now I'm more focused. You guys okay? Okay, I don't know. It is weird. Okay, so this is gross. Do you guys agree with me? Anybody? Do you guys agree? That's gross. How the hell am I going to solve for that? All right. Oh, man. So let me just tell you. First thing I would do is divide by 2. Do you guys, does that make sense? I want to get that. So let me start to strip away the shit. Let me divide by 2. Die. Now I'm left with this. Oh, you're dead, aren't you, you poor little thing? Is everything cool? 0.03 divided by 2 is 0.015. Yes? Yes? All right, stay with me. Let me use a better marker. Get out of here. Hey, I made it. Oh, I'm sorry. You guys can't see. What do I have to get out of the way next? See, I got the 2 out of the way. Sorry?
The square root?
Square root. Good. What's the opposite of a square root? We talked about this before.
An exponent?
Yes, specifically a square. So can you guys help me? I think I could figure this out. But what is 0.015 squared? Is it shit. 0.00625? I'm probably way off. No, I'm way off. I don't know what it is.
0.000225 question mark?
0, how many zeros?
3 zeros.
3 zeros and then 2,
2, 5.
225. Okay. Oh, Jeff, you're so funny. All right, sorry. I just realized what I did. So everybody, all right, those are gross numbers, correct? Aren't they gross numbers? All right, I don't care because they're in the calculator. Who cares? Now look at this. How am I going to get that? How am I going to solve for that? Doesn't it suck that it's down there?
Yeah.
You guys agree? It's easier to solve this equation for x than it is to solve this equation for x. Would you guys agree with me?
Yes.
It's easier when the variable's up top. So why don't I just multiply by n?
And mhm.
And then I can divide by this. Won't n be by itself then? Don't worry, I'm going to give you the formula here in a minute to do this all in one big step, right? Can somebody please do this in your calculator? I'll do it too. Let's see what we get. Oh boy. Neato. Okay, I got it. I got it. I got it. So 0.725 times 0.275 divided by this crazy thing. You guys, anybody? All you gotta do is put in your calculator. This time it's divided by this.
I got 886.
886.1.
You always round it up because I don't want to take 0.111 of a person, do you? I don't want to have you guys out there killing people and chopping them up, right? I only need your finger. Ah, no! So let's round that up so we get a whole number of people. Does that sound like a good idea? Okay, so I would have to have 887 people to talk to. So I went from 407 to 880. So we'd have to talk to another 480 something people, or 480. Yeah. Do you guys understand? Then we can figure out, is it worth it? Do we have the time? So if I talk to 400 and some people, the error was 4.4%. If I make it 887 people, the error will go down to 3%. I love you guys. So let me do this. Okay. So doesn't this make sense? What you want to know, how big of a sample do we have to take to get the error down to something? Doesn't it make sense if you're a statistician? Like, how big of a sample will I have to take to make the error 3% or 2%? Maybe? No? No? You guys don't want to talk to me? You're like,
Yeah, I mean, it makes sense. Like, so the error, you're kind of diluting the error, correct? Like,
yeah,
with more people, the more
Exactly.
people you add into it, the more like diluted your error is going to be.
yeah, I
Because the
like
more
that.
precise your percentage is going to be.
Yeah, the more you can trust your results.
Yeah.
So I call this a feasibility study. If I want the error to be 1% and that requires me to talk to 1 million people, I'm like, I'm going to try to live with a higher error. I'm not going to talk to 1 million people. It is a feasibility study. Feasibility, do you guys know what that means? Something's feasible or not means, do we have the resources to
And
do it?
you can make it happen.
Yeah, we can make it happen or not, right? So 1 million, maybe not. 800 something, okay, we could do that. All right, so let me, you guys, I'm going to erase all this. You ready?
Just a minute, Professor.
Sure.
Yeah, if we put the number at the calculator from the beginning, we can't have the result from the beginning or no?
How do you mean? Sorry?
If I put the equation, yes, from the beginning, I didn't do all this stuff.
What
Exponent and everything.
What equation though?
Yeah, two exponent 0.725 times 275 over 9 equals 0.03.
Over
Only this one.
Over 9?
Divided by n. Sorry, I'm fast.
How would you figure out what this is without doing these steps? I don't understand. How would you get here?
This is my question. If we got this, we can't in the calculator, we can't find the n. No.
The calculator doesn't know what to do with this, right?
Okay. Okay.
So what I'm about to show you is what does the equation look like if it's solved for n already? Wouldn't that be nice? If we had an equation that was solved for n?
Uh-huh.
All right, so that's what I'm about to do. Here we go.
Okay.
All right. All right, I'm gonna do it relatively quickly, which means if you don't quite totally understand it, that's okay. Do a little quickly, but I'm basically gonna do all the same steps we just did. Divide by 2. Remember, that's what we did first. Then we square both sides. That's what we do next. And now the next step I'm going to do a little bit quickly. Now this gets a little gross. Just stay with me. Let's see, what's the best way to do it? Let me do this. Let's cross multiply. See what you guys think about this. You guys are hating this, I know. And then I just have to divide by e squared, and I get my n by itself. Jeff, how many things does an e have? There you go, buddy. So that is the equation to solve for n. So now I could just put directly, let's try it. Let's try this equation out. Let's put all the stuff we know. N equals 4 times 0.725 times 0.275. How many parentheses you need, Jeff? Divided by 0.03. I want to be 3%, right? Squared. If you put that in your calculator, you will get 800. You'll get the same exact answer we just got a second ago. I really hope I didn't screw something up. What? Oh, I see. Jeff, you're so silly. There you go, buddy. Oh, there you go. I got concerned for a second. Is anyone going to try to do that? Are you guys trying to do that? If you put that in your calculator, you will get 886 point blah, blah, blah. We round it up to 887. So this equation is a shortcut equation that solves for what n first. And now I can just put my stuff in to figure out how big of a sample I need. I don't have to solve for n every time. Isn't that nice?
Yes.
Okay. I know I went a little quick on this, but it's basically the same steps until I got here. It was just easier to cross multiply to get there, but yeah, okay. All right, so now in the homework, if they say how large of a sample do you need to take to be within 2%, this is what you use, and you make E 0.02 to be within 2%. All right, and now you're all statisticians. Welcome to the club. Is everybody cool with that? I pushed it away because I'm evil. So really, all you need is this. This is the formula for n. And it's trying to be a p there. Okay. All right, so let's take a look here. Oh shit, where am I? There I go. I don't even think the book gives you that formula. Let me see. Those assholes. Let me see. No, they don't. Here we go. Let's try this problem out now. Let's see if anybody yells at me if I do this. Bam. Number 17, page 495. Let's take a look. Let's see. So suppose the result of a public opinion poll shows that 9% of people would be willing to give up their cell phone for 1 week in exchange for $100. How many of you guys would do that? Somebody would give you $100 and you give up your phone for a week. Is that enough money?
No.
I had a feeling the answer was no. All right, sorry. So somebody was saying you go for a month to a cabin with no cell phone or Wi-Fi or anything, and they'll give you $100,000. I'm like, dude, I would pay money for that. What are you talking about? Give me the 100,000. Jeez. All right. So this, they already did what? They already calculated what for me? What does that 9% represent? Does anyone know? Does anyone remember? They already calculated it for me. What does this represent? What symbol does that represents that?
P hat.
Good. That's P hat. I love it. So what's 1 minus P hat? If P hat's 9%, what's 1 minus that? What's the rest?
91.
91.
Fine.
So
Fine.
0.91 as a decimal, right?
Yeah.
What number doesn't mean anything that we're not going to use in our equation? What number do they give me that I'm not going to use in my equation?
$100.
$100 has nothing to do. It's just the situation. It's not a real number that's going to go in my equation. It's just the situation. And what's the error? How much do I want to be at most off by? They tell you directly. What's the error?
2%.
2%. So I'm going to write down 0.02. Always make sure your percentages are decimals before you plug them into an equation. So now we've got everything we need. So now if I use my formula, n equals 4 p hat 1 minus p hat divided by e squared. Good, Jeff. All right. Wait a minute. Go away. All right, Jeff. There we go. That's the formula we just came up with, right? To figure out what the sample size of how many people, that's going to be n equals 4 times 0.09 times 0.91. How many? All right, divided by 0.02 square. And that's something people always forget, that poor little square. So see what we get. Do it in your head, Jeff. Why? Because, okay. Let's see. 100 plus 10,000, 10,000, 1,100. Oh, okay. So it's going to be 819. I think exactly. Oh, dude. All right. Is that really right? 819. I agree. So we don't have to round it up. It came out perfectly to 819, right? I did it in my head. I did it in my head. Who gives a shit, Jeff? We did it in a calculator.
Yeah, that's right.
Okay, good. All right. Anyway, you too could do what I can do. You could. And I can't. This is all I can do. All right. So we have to survey 819 people to have a 2% margin of error. That's not bad, actually. All right, let me clear this away. Clear. You ready? I'm going to clear it. Clear. All right, that's really all there is to this section. The main formula for the confidence interval stuff. So this is the formula, the main formula. Oh, okay, I like that. Let's see. How many more would need to be surveyed? That's going to be the other formula, the n equals formula. The book doesn't even give you that formula. So you're welcome. And then they use some weird shit, but I'm going to let you guys have fun with that. Haha. Okay, and a little bit of a look ahead. We don't do section 4.4 just because we don't really do much with inverse variation, really. So we don't really talk about that. So the next thing we're going to do is section 4.5, which is going to be where we start talking about exponential growth and decay. Have you guys watched enough horror movies? Have you ever heard somebody go, it's growing exponentially or something like that? No, or maybe not with that tone. I know it's growing exponentially, or a virus.
Blob.
The Blob, exactly. That's what I'm thinking about. Or a virus, you know, some sci-fi movie where a virus covers the whole world, or maybe it happened in real life. And they say tomorrow it's here, and the next day it's the whole world is exponential growth. Or you could have something where it's not a monster or a virus killing people. It's like money growing in an account, or it could be radioactivity. So it's losing radioactivity. So it's called exponential decay. Has any of this stuff ever been heard by you guys?
Yep.
Yep. So we're going to talk about, now the reason we call these exponential functions is because where is the variable? Where's the input variable for this? So there's y, that's the output variable. Where's the input variable? Where is it?
ABX.
So where is that? What is that? X is the what? Not the variable, but it's in the position of a what?
Input.
Exponent. It's in the
Yeah.
position of an exponent.
Exponent.
So math people being really smart, we call these exponential equations because the variable is in the exponent. Isn't that? Oh, good job, math people. Okay. All right. But I think that's enough. We'll get into this tomorrow. I think that's enough for today. So be sure to come. All right. So today, I think I've gotten everybody else. I forgot to do this. So if you have a problem with, I try to always spotlight myself. You might show up on the video. So I'm sorry. Because if you talked, you will show up on the video. If you have your camera on, I'm sorry. If you have a problem with that, I just won't post it. Anyway, so that's enough for today. So you guys can leave. Let me know if you have a question, if you need to hang out. I've got my office hours also starting at 11. So if you want to come then.
Thank
I
you,
have a
Professor.
question.
Sure, Tristan. What's up, Sabrina?
Yeah, sorry, I got stretched. So on number 4,